between like, or I'm sorry, bear length between say 120.5 centimeter, and what was our largest, 166? So any bear length in between there, we could, again, estimate what that bear weight would be. What values do you think? What should we use? Somewhere between 120 and 166. What do you think? Somebody pick a number. Any number. 141. Okay, so let's say a bear is 141 centimeters long. Somebody give me another X. Between 120 and 166. I mean, come on, how hard is it? Sorry? 150. 150? Okay, perfect. We will also estimate the weight of a bear that's 150 centimeters in length. Okay, so to do this, go back in your regression output. We can go up to options and edit. And you'll see, if you scroll down a little bit, where it says prediction of Y in kind of bold lettering, and it says X value or values. In that box, you're going to type 141 and then a comma and 150. And I don't think you put a space, just 141, comma 150. Are you guys with me? Did you find it?
So it's
Where it says prediction of Y. Okay?
it would be
Above it. The box right above it. Right above it, where it says prediction of Y, where it says X values.
Oh.
Down, 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 yeah, there. The box above where your cursor is. Yeah,
okay, so it would be what's the number again?
these guys, 141, comma 150. Okay. And then if you hit compute, you'll see down at the very bottom of your output. Now you could find these values also by plugging in 141 into your regression equation, 150 into your regression equation. It'll give you output. But down at the bottom it'll say predicted values, and it'll give you your X's. There's our 141 and 150, and there's our predicted Y's. So you can have StatCrunch do it. 96.4. So if a bear is 141 centimeters, we expect their weight to be 96.4 kilometers. Kilometers, I'm going. Yeah, thank you. And if a bear is 150 centimeters, I'm thinking length and length, 111.7 kilograms. Okay, you can type in one value there, you can type in 4. Just separate them by commas. You guys with me? Everybody get that okay? Okay, Julio.
I tried to compute it, but it didn't let me. It says the value of
Oh, no. Like you type them in that one box together.
oh really? Oh, no.
Up, yep, comma, and then the 150.
Okay.
There you go.
Wait, it's still the same value. I still have
I think because you took out the, at level, type back in 0.95.
Put one in there?
No, 0.95.
Oh,
There you go. Predicted values right at the bottom. Okay. Okay, so that's how you would make predictions with StatCrunch. And again, ultimately, that's our goal, to use this tool as a predictor. Okay. We talked about deviations. The next thing in 4.3, the couple of, we talked about finding residuals, right? If you want to find individual residuals, where you have options, let's go back into the menu. If you go down where it says save, and you click residuals, and compute, you'll get the residuals in your output, all of your individual residuals. For a bear that is 141, centimeters in length and weighs 95 kilograms, that's a residual of negative 1.4067, blah, 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 blah. So it gives you the individual residuals. Notice some are positive and some are negative, because some of they're calculated. Let's look at the actual graph, and then let's talk about how they're calculated individually. So again, if you click on the little arrow at the bottom, and I'm going to maximize my graph. So each residual is calculated by the observed y minus the predicted y. They're calculated based on y values because they're vertical distances. And y is our vertical value there. So I think we talked about this guy. So right there's a data value. I'll make it nice and big. Right there's a data value. Right here would be the observed y. Observed because it comes from the data we observed. Okay? But at that value of y, it would get predicted by the line, which is here. So there's the predicted y. Each residual, each one of these vertical distances, is calculated by the observed y minus the predicted y. Okay? Now, any value that's larger on the y-axis is going to be above, right? So if you go observed y minus predicted y, that's going to be a positive value. Do you agree? Because this number is going to be bigger than that number. Do you agree? Does that make sense? Okay? So that's going to be a positive residual. The number itself is going to be positive, but it's an underestimate because the value, because the predicted y is less than. Where this number is getting predicted is smaller than what we observed, so it's actually an underestimate. Positive residual is an underestimate. Why? Because the observed y, get it? The observed y is larger than the predicted y. The smaller the distance between each data value and the line, the smaller that residual is going to be. This data value is under the line. It's going to be a negative residual, but it's going to be an overestimate because the line is above the actual data value. Does that kind of make sense? Just the relationship from the line to the points. So each residual, again, is the vertical distance between each point and the regression line. So you have in your spreadsheet all of the individual residuals. If you're asked to find one specific residual, you have that, okay? And, let's see, I got rid of my impression here. And if you were asked to find the overall error, which is going to be given as the sum of the square of the residuals, the sum of the residuals squared, or the overall error, all the error, it's given by, whoops, in that regression output. So this thing is magical. It's pretty much everything you need. Where if you go down where it says analysis of variance table for regression model, where it says error, okay, where it says error and there's a number right there, that's your sum of squared residuals. It's the overall error. Okay, so the sum of the squared residuals for the Bayer data, 4350. .4367. And the bigger that number is, the further away each data value, let me rephrase. The bigger that number is, the bigger the distance is from each data value to the line, right? The more the overall distance, the further away the data points are from the line. And therefore, your R value is going to go down. Your R value is going to be closer to 0, because remember that's when an R value is not good, it gets closer to 0. So as the error goes up, the R value gets worse. And here we had 0.704, not bad, but not great. The overall error is going to be kind of big. Is error bad in this case? No, we expect it. We expect it. Again, real life data where, you know, the regression line could go right through all the data points, it doesn't exist. So, and again, when we do our predictions, that's just what they are, predictions. Let's see, was there any other thing we wanted to do? Yes, one more thing we want to do. Even though, you know, the rest of this stuff kind of, you know, looks good, we want to take a look at a residual plot. So a residual plot kind of, even though, you know, all these numbers come out fairly well, we could still have a model where the linear, let me rephrase, we could still have data where the linear model is not the best. So the residual plot is another way of validating what we're doing here, okay? So if you go to back to that regression output, and you scroll down to where it says, let's see, graphs, where it says graphs, and you'll see it's already been, the fitted line plot, it has already been selected. You want the residuals versus the X values. So where it says residuals versus X values, and you get your output back, and then at the bottom of the data you'll get an arrow. Okay, and notice here at the top it says residuals versus total length. And as opposed to the beginning of the process where we wanted a pattern to the data values. This isn't the data values anymore, this is the residuals. You want no pattern in the residuals. You want no pattern whatsoever. If a pattern exists, it tells us that the linear model may not be the best for what we're trying to do here. May not be the best. But this looks good, this is what we want, just a big mess of nothing. Perfect. A lot of times residuals will have this shape where they kind of look like they'll like start out narrow and then funnel out, or they'll have like a U shape or something like that. You don't want any shape, any discernible shape whatsoever. Okay. Wow. I'd like to start from the top and do a problem all the way through with all this stuff that we've done. Does that sound like a plan? And we'll talk about what each step means. And again, this section 4.1, 4.2, 4.3 just all kind of run together. We'll probably have to finish it up next time, but that's okay. We will do so. Data. Okay, let's do data 4.1, excuse me, 26. Data 4.1, 26. I don't think we've looked at this data yet. It is, it's FICO scores. It's your FICO credit score. So Fair Isaac Company, whoever in there, they gather data on your credit history, how good you've been at paying your bills. You know, do you have a credit card in your name? Do you pay your credit card bill? Do you have a car loan? Do you make your car payments? Blah 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 blah, stuff like that. So based on your credit history, they give you a credit score. If you were going to go, say, make a major purchase, like if you're going to buy a house or you're going to buy a new car or whatever, they're going to give you, the better your FICO score is, the lower interest rate you can get. Because they're like rewarding you for paying your bills. Thank you. So, if you can see that as the credit score, so here's 6 individuals, their FICO score, and the interest rate that they can get on whatever this major purchase is, either a new car or a home or whatever. Or just a personal loan, right? Just a personal loan. Okay, so as their credit score increases, what should we see going on with the
Decrease.
it should decrease, right? We should have some kind of a negative pattern. Let's take a look. So again, our first step would be to graph this thing, this data, and see if we can get a nice linear pattern out of it. So we go graph and down to scatter plot. X variable is the credit score. So based on your credit score, what kind of interest rate should you be able to get? So X credit score, Y interest rate, and let's go compute. Okay, and for the video, let's see, I'll make my point size a little bigger. Here we go. So it looks like we have a really nice negative linear pattern there. Do you agree? Look good? Okay. So first thing we would do is a scatter plot. And if we were being asked to comment on that scatter plot, we would say, as credit score increases, interest rate is decreasing overall. We're in general. In general. Okay, next is our R value. Okay? So step 2, we see a nice linear pattern here. Let's go on and get an R value and see what kind of R value. Do you have a guess at what the R value is going to be, given how nice and lined up that data is?
Close to -1.
What's your guess? Closer to, it's going to be closer to -1, right? Right? How close do you think? Just a guess? Point 0.9? Yeah, it's about 0.9 something. It's really strong, don't you think? Cool. It's nice to just kind of have that sense of what these values all mean. So stacked, regression, simple linear. Our X is credit score, our Y is interest rate. For right now, let's just go compute. We can always go back and generate more stuff that we need. Okay, so there's our R value. And we were right, you know, -0.976. Again, your R value is going to show up in this top, and it says correlation coefficient, -0.976. We knew it was going to be good. Are we surprised that it's negative? Does it make sense that it's negative? Yeah, because the data is showing a negative kind of a slope. Yeah? Okay, cool. And let's say what this R value means. An R of -0.976 means, do you think we could say a very strong?
Yeah.
I think we can. Means that there is a very strong negative linear relationship between credit score and interest rate. Okay. How about the regression equation? Oh, and hey, you guys, if you click the little blue arrow at the bottom, you have a picture of the fitted line with the data values. Remember that the residuals are the vertical distances between each data value and the line. The sum of the squared residuals, should that be what kind of a number is that going to be? Remember, the sum of the squared residuals takes all these vertical distances, squares them, to make them all positive, and then adds them up. Pretty small, good, yeah, it's going to be a pretty small number. Because the stronger the R value is, The closer the data values are to the data points are to the line, the smaller the overall error, and the smaller each individual residual. Individual residual, say that 10 times really fast. Okay, so regression equation. So is this all kind of coming together for you? Yeah, good, I'm glad. I hope so. Okay, there's our slope and intercept. Remember, that's right at about the middle of your output. There's also, it gives you the regression equation at the top in terms of the actual variables, interest rate and credit score. But they're also just out in the middle individually in your output. So the regression equation is y hat. What's the slope here? Negative 0.076. .076? Yeah, got my decimal in the wrong one. X plus 61.37. Yeah, great. Okay, let's talk about the meaning of the slope and the utility of the y-intercept. Does the y-intercept have a meaning in this case? So remember, at the y-intercept, what's the value of x? 0. Do we have any zeros in our x's? No. Well, there's one reason it's not meaningful here. It's not in our observed data. Again, once in a while it can be. In this case, no. Bless you. And so, if somebody has a 0 credit score, ooh, they probably can't even get a loan at all. So it wouldn't matter what the interest rate is. Nobody's gonna loan them money. They don't have a FICO score. Anyway, it's so far outside the realm of our data, it wouldn't make any sense at all. So let's write that. Y-intercept has no meaning. Because it is we can just say outside the realm of our data, or outside our observed data. We would have no idea what happens there. Okay, remember the slope always has meaning. I never ever thought I would say this in a million years, but I am damn sick of the heat. Are you guys?
I am too.
Just sick of it being so hot.
I'm tired of it.
I know.
It's actually more hard now than in July.
Yeah, bring on the winter. Get
I'm
ready.
almost-
We're all gonna be ready, right? Let it be
I
cold.
think it's fall already, or it's like almost fall.
So my prediction is we're gonna go straight from summer to winter.
Yeah, we're not gonna have it.
We're not gonna have a fall. Okay, never thought I would say that. Love summer, not this year, not this year. Okay, so our slope, it's negative 0.076. Think about it over 1. Let's look at the units. Our credit score, I think it has its own units. It's just credit score. And our interest rate is in percent. So what you want to talk about as X changes, let me rephrase. For every unit, 1 unit change in X, how does Y respond to that? What happens to Y? So it looks like as your credit score increases, your FICO score increases 1 unit, the interest rate you can get is gonna go down by about 0.076%. Make sense? Cool, let's write it. For each additional unit of FICO score, your interest rate decreases. Why does it decrease? Because the slope is negative. Your interest rate decreases by 0.076%. .076 of a percentage point isn't very much, but neither is 1 unit of FICO score. Let's talk about this. In StatCrunch, what they might do is ask you for a 10 or 100 point change in X. So if that were the case, let's say if your credit score increases by 100 points, does that make sense? If your credit score increases by 100 points, your interest rate will decrease 7.6%. So I think there's some questions in there that they ask you in terms of hundreds. So bear that in mind. Okay. So we have that. Let's make a couple predictions. What do you think? Give me a couple X's within the realm of our data. Or we can just do one. Somewhere between 545 and 750. Sorry? 680? Okay. So let's say you have, thank you. Let's say you have a FICO score of 680. What kind of an interest rate can you get? So you could either plug 680 into the regression equation, okay, in for X, what's the predicted Y? Oh, and let me add this on the meaning of the slope. In general. So that change happens in general, not absolutely specific. Okay, so we can go back into StatCrunch, go options, edit, and then go down where it says prediction of Y, where it has X values. Let's type in 680. And compute. That output is going to be at the bottom of your output there. You can get, so if you have a FICO score of 680, you can get about a 9.4% loan. Does that make sense? You guys with me? We good? Okay, cool. And again, approximately. And again, we don't know what's gonna happen outside of the realm of our data, so we don't go there. Okay, we can generate the residuals, right? We can find the overall error. Oh, we already have it actually. Remember, if you go back to options, or if you go back to your output and down to save where it says residuals, you can save those residuals. And you don't, and there they are in your output. You don't even have to generate them to get the overall error or the sum of the squared residuals, because it's right here. Error, and SS means sum of squared. Sum of the squared errors or residuals. 8.11, isn't that a big change from our bare data? It was like 43 something, wasn't it? Something really gigantic. So that's another thing we would want to do. Find the sum of the residuals squared, which in this case is 8.11. But again, the stronger your R value, the smaller that number is going to be, because it's saying that the points are close to the regression line.